From a piece of cardboard that is 8 inches by 8 inches, square corners are cut out so the sides can be folded up to make a box. My drawing is not to scale because this is supposedly 8 inches total by 8 inches. What dimensions will yield a box of maximum volume? What is the volume? Okay, so before I worry about the volume, let's get some variables on our piece of cardboard here. So let's say that these squares that I'm cutting off the corner of my box are x by x, and all of them are going to be that. Then, when I go to fold it up, that right there is going to be the front side of my box. Okay, and what is that length? If the total length here is 8, and I'm taking away that much, what's left?
8 minus 4x?
2x.
2x. Oh.
Good, yes. The total was 8, and I'm taking away x here and x here. So the front of my box here is 8 minus 2x. Okay, and then since it's a square piece of cardboard, that's also going to be that side, right? Every side that I fold up is going to be 8 minus 2x. But I also need the height of the box. So when I fold up that piece right there, how tall is it going to be? X. Good. So my volume then is x times 8 minus 2x squared. Okay? Now, if we're going to take a derivative of this, it's going to be easiest to multiply this out and just power rule it, right? If I do it now, I've got a product rule and a chain rule, and I don't want to deal with that. So we're going to multiply this out. So I get x times, so we're multiplying out 8 minus 2x times 8 minus 2x. The first gives me 64. Outer gives me minus 16x, and inner gives me another minus 16x. So I get negative 32x. And my last, negative 2x times negative 2x gives me 4x squared. And now if I distribute this x, I'm going to get 64x minus 32x squared plus 4x cubed. We want to take the derivative of the volume formula. So when we do this, it's just going to be power rule. We're going to get v prime equals derivative of 64x is 64. Derivative of negative 32x squared, 2 comes out front. We're going to get minus 64x. And derivative of 4x cubed, the 3 comes out front. I'm going to get 12x squared. Okay, so I rewrote the derivative there so that I can see it's a quadratic. Now, if I'm going to have to factor this thing, because I got to set it equal to 0, and then I'm going to have to factor to get my x values, I see that there's a greatest common factor of 4 I can pull out, and that's going to make my factoring a little bit easier. So when I set this equal to 0, I can just divide both sides by 4 and get rid of that. Okay. So I need to factor this thing. The leading coefficient isn't 1, so it's not so easy. You can use whatever method you choose to factor. Some of you might like guess and check. I don't happen to like that method. I like factoring by grouping, but in order to do that, I have to split up this middle term. So there's a couple steps involved there. When you're factoring, and this is actually true, even when the leading coefficient's 1, we don't have to go through the whole process though because it's just 1, but it's actually what we're doing. You just don't know it. I'm looking for a sum of the coefficient of the middle term. So I want to get two numbers that are going to add up to negative 16, which is my middle term. I'm looking for the product of the first coefficient times the last. So when the leading coefficient's 1, we're just trying to get a product that adds up to the last. But now it's 3 times 16, which is 48. So I'm looking for two numbers that are going to add up to negative 16 and multiply to 48. Okay, so you just kind of go through. 1 multiplies to 48. 1 and 48. Okay, that's not going to add up to 16. 2 and 24. That's not going to work. What did you say? Negative 12 and negative 4. Okay, so the purpose of this is to find two numbers that I can split negative 16 into, because negative 4 and negative 12 add up to negative 16, right? So I'm going to rewrite this thing as 0 equals 3x squared minus 4x minus 12x plus 16. Factoring by grouping is what we do when we have 4 terms. I group the first 2 terms together and the second 2 terms together. Now looking at the first 2 terms, what can I factor out? What's the greatest common factor? I can pull out an x, and that leaves me with 3x minus 4. For the second group, I always pull out the sign of the first term. So I'm going to pull out a negative. And what is the greatest common factor between negative 12x and 16?
4.
So if I pull out a negative 4, that'll leave me with 3x minus 4. So these two factors match, and they have to match for this to work. That becomes one of my factors. So I have 0 equals 3x minus 4. And what's left in front of those is my other factor, x minus 4. So these two factors, if I set each one equal to 0, they're going to give me x values of 4 from that one. And from this one, I add 4 to both sides and divide by 3. I'm going to get 4/3. Okay, so we found a value of 4 and a value of 4/3. Let's go back and look at our box for a minute. If x equals 4, what's going to be this length?
Oh, that's 0.
It would be 0. So 4 is not an option here. So x must be 4/3, and that's the height of our box in inches. And if x is 4/3, we know that the other two dimensions were 8 minus 2x. So I get 8 minus 2 times 4/3 would be 8/3. And 8 times 3 is 24. So 24/3 minus 8/3 will give me 16/3. So the dimensions of my box are 4/3 inches by 16/3 inches by 16/3 inches. And we were asked to find the volume. So if I multiply those together, I get, I'm going to bring it up here, a volume of 1,024/27 inches cubed. And if I make that a decimal approximation, because that makes a little bit more sense to me if we're talking about volume, if I really want to know how big this box is, a decimal answer is going to make more sense to me than that fraction does. It is 37.93 inches cubed. Okay, another box problem, but this one's a little bit different. I'm already given the box, and it has a surface area of 108 inches squared. Okay, so that means if I take all the sides of the boxes and add their areas together, I'm going to get 108 inches squared. And it's an open top box, so I don't have to worry about the top being part of the surface area. What dimensions will produce the maximum volume? So it has a square base, so let's label this and this as x. And then we'll make the height h. So my volume is going to be length times width times height. That's just going to be x squared times h. And that's the equation that we're going to want to maximize. We're going to use the surface area equation to find one of the variables. So our surface area is given to us as 108 inches squared. And so we have to figure out what is the area of each surface that we have. Well, the base of this thing is going to be x times x, right? It has a square base, and we're calling the dimension x. So we're going to have x squared for the base. And then for each side, I have 4 sides that are all going to be x times h.
So 4.
So plus 4xh. So I need to use that equation to solve for a variable. Which variable is going to be easiest to solve for? H is. So let's subtract x squared from both sides. I get 108 minus x squared equals 4xh. We'll divide everything by 4x. And I get h equals 108 minus x squared over 4x. And if I plug that into my volume formula, we're going to get x squared times 108 minus x squared over 4x. And so that'll simplify a little bit. my x squared will cancel with that x there. And if I distribute the x that's left, 108 divided by 4 is 27. So I'm going to get 27x. And here I have x squared over 4. That 4 is not canceling with anything. Multiply it by the x, I'm going to get an x cubed. So this is minus 1/4 x cubed. So that's my volume formula.
Wait, can you go back?
So our equation is, our volume is 27x minus 1/4 x cubed. We want to take a derivative so we can optimize it. And I get 27. For my second term, 3 comes out front, so I get minus 3/4 x squared. Then we set that equal to 0. I'm going to add 3/4 x squared to both sides. And I want to get rid of the 3/4 on both sides, so I'm going to multiply both sides by 4/3. And when I do that, I get x squared equals 36. Okay, 27 divided by 3 is 9, and 9 times 4 is 36. So x equals what?
Plus or minus.
It would be plus or minus 6, right? But we're talking about a dimension of a box, so we only want the positive. So we're just going to say it's positive 6, and that's in inches. Okay, if x equals 6, we need to go back to our equation for h. To get the other dimension of the box, right? Because it's x by h. So we're going to plug x equals 6 in here, and I get 108 minus 36 over 4 times 6 is 24. That's 72 over 24, which is 3. So the dimensions are 6 inches by 6 inches. That's my x by x, by my h of 3 inches.